Welcome to Good Day AWWA. Here's your host, David LaFrance, CEO of the American Waterworks Association.
Welcome to Good Day AWWA. My guest today is Colby Manwaring. He is the CEO of Innovyze. Innovyze is a global leader in building innovative software for the water industry. They're also the sponsor of Good Day AWWA, the entire series of Good Day AWWA that will be showing during ACE 21, all virtual. So let's invite Colby in. We're going to have a little bit of breakfast, and we're going to talk about technology and water. Colby, welcome to Good Day AWWA. Thanks for joining us.
Hi, David. It's fantastic to join you. It's an honor to sponsor the series and to participate in this session. So let's have some breakfast and some chat.
Yeah. So thank you so much for picking what looks like chocolate deliciousness for breakfast. Not a common breakfast for me, but tell me a little bit about why you selected this breakfast for us to have.
Sure. So I'm sitting in Star Valley Ranch, Wyoming, where the buffalo roam. And so thanks for the acknowledgement there with the buffalo picture. This breakfast that I've chosen has nothing to do with Wyoming. Over the course of my life, I've traveled and lived actually in many places. England, Spain, Australia, Portland, Oregon, which is a whole different country than Wyoming. So several places. I've chosen actually a Spanish breakfast. When I was 19, 20, I lived in Spain, and I'm not a huge breakfast eater generally. And so this Spanish breakfast is perfect in that it's a thick, a drinking chocolate, but a thickened drinking chocolate. And you dip magdalenas or kind of lemon flavored cupcakes or churros in this chocolate. And you're done quickly. You get a big sugar high and off you go for the day.
All right, let's give it a try.
Absolutely. Looks like you're going to need to give it a lot of tries. I've got a small cup.
Yeah.
Typically, a little espresso cup or bigger would be normal. You've got a family-sized cup.
Yeah. Okay, that's good. Maybe the rest of the interview could be watching me eat this entire thing. That is, I can't believe you had that for breakfast every day. That's a great way to start the day.
Well, you can do that when you're 20 years old. Probably can't do that now.
Perfect. So Colby, let's get started. I think it would be interesting for our audience to hear about when you figured out that technology was really a strong part of our future. And what was that moment when you decided to become, a leader in technology, especially a leader in technology related to water?
Yeah, it's a great question, David. So I was in undergraduate school at Brigham Young University, civil engineering, water resources emphasis. Every week there was an engineering seminar. The one class you could just go and relax, right? You just sat there and listened to various industry leaders or people kind of present what they did and what career paths are there. So in one of those seminars, a representative from the Engineering Computer Graphics Laboratory at Brigham Young University presented some environmental modeling software and, visualizing all sorts of things. It was actually groundwater and surface water and so on. So it was water related. And as I sat there, I said, looking at this software, 3D visualizations and the powerful tools that have been built to do environmental modeling, I thought, that's what I'm going to do. I want to build software tools to make engineering faster, easier, more effective. And the next day, I went to that research lab and I applied for a job as a developer, as a programmer. They asked me if I could program. I, of course, said, absolutely, yes, I can. And then I quickly learned how to program over the following couple of weeks.
That's great. And look at where you are today, right? CEO of one of the great leaders in that whole area.
Yeah, water software is my life. and I believe it's a way forward for the entire industry by leveraging technology, leveraging all this computing power.
So let's talk about that way forward. The thing I hear a lot about these days is digital twins, right? And for the rest of our audience, can you talk a little bit about what a digital twin is?
Of course, yeah. A water digital twin is a dynamic representation of a real world system. It's used to describe, diagnose, predict, optimize actions in managing that water system through a combination of behavioral predictive models, through analytics, pattern recognition, essentially tapping into real-time data as well as asset information data that allows us to essentially explore in the cyber world the things that might possibly help us in the real world.
Okay, so as we're thinking about this model, this digital model, who do you see using it in the water space? And do you see it just as a tool for big utilities, or is it a tool for small utilities, every utility? What about manufacturers of products and valves and pipes and things like that? How does it work?
Well, the great thing about digital twins is they are actually very scalable. There is not a template. There's not a one size fits all digital twin that does certain things the same way for everyone. As such, small utilities, medium utilities, giant utilities, individual, just one plant, right? One water treatment plant would benefit from using a digital twin. The whole idea around the digital twin is just to empower a higher value of work product from the engineers or the planners or the CEOs or the CFOs of water utilities. The size issue should not be a factor. I think there's a common perception in the market that it does take, millions of dollars and hundreds of people dedicated to a digital twin, and it's not true. The first question anyone should ask is, what do I want out of my digital twin? And if it is optimizing one pump, well, that's a relatively small digital twin, and that's a relatively small operation, but you still get great benefit.
So let's go to the idea. You said scalable, and I think this will help folks understand. You said if it was just one pump, right? So we've got that idea. Could it be an entire treatment plant? Could it be, if a utility has a series of treatment plants, could it be all the treatment plants plus the connectivity, the sort of infrastructure connectivity? How far does it scale?
Yeah, so it's a little bit dependent on the what you want out of it, but it scales from the single unit, so a single operational unit like a pump, all the way to citywide network plus plants plus consumers. I mean, the whole thing truly a digital world. I don't know if you used to play Sim City way back. It was one of the first simulation games for civilization, right? Sim City is a similar idea, and that you can start quite small and then you build out and build out and build out and build out until you really could run an entire utility operation for Nashville, Tennessee, with a digital twin, from pumps to plants to valves to customer interactions.
All right. So as a utility is using their digital twin of their system or their facility or their single piece of equipment, what is it they're trying to gain? How does it help them to do
Sure.
that process? I mean, they're not actually pumping the water. It's a digital simulation of that, right?
Well, the value in a digital twin is understanding what has happened. So you've got your system and you've got past events that your digital twin should be able to replicate and show you, in fact, that the digital twin is reproducing real world events. So you know what has happened. Now there's value in that, and that you might diagnose things that went wrong. You might better understand future needs for your network or your plant or your pump. The second thing that it can do is tell you what's happening right now. So situational awareness. Wouldn't it be great to know that there's a water main break right now, rather than in an hour when a customer notices and calls and says, "Hey, there's water, coming out of the ground in front of my house. What's that about?" Right? Even if it's only an hour, how many gallons have been lost? The third part of what does it do, what's worthwhile, is what's next. So this is where we get to the behavioral modeling, the predictive analytics, where the digital twin can say, "Hey, based on what I'm seeing right now, with the data that's coming in right now, here's what's going to happen next." And if what next is, hey, that river's going to break its banks and flood out onto Main Street, then a good digital twin can also give some prescriptive actions to take. Right? This is not exactly rocket science. If the water's coming out of the river, you should sandbag the river, put up the flood wall, whatever it is, the action that can be taken in your community. But the digital twin can give more accurate, immediate advice on what to do next, allowing the people that are involved in digital twins. And this is important, right? Digital twins are not about the machines taking over the world. Digital twins are about empowering people to be more effective at managing water and managing our communities. So advice to the operators or to the engineers or to the asset planners on what do you do next to optimize whatever it is you're trying to optimize, right? My optimization's problem is I don't want flooding on Main Street. Others' optimization problem is we want to consume less energy. How do we do that? Again, a digital twin, if it knows what has happened, it knows what's happening now, and knows what's going to happen next, it can provide prescriptive analytics to help meet objectives.
I think that predictive capability is a pretty powerful value add for any utility that is trying to plan ahead. All right, so we've just been talking about this great technology. We've been talking about utilities. Utilities historically are sort of slow adopters of innovation and technology. They're faster today than they used to be, right? So they're getting a lot better.
Sure.
But how do you overcome that? I mean, you're bringing cutting edge stuff to them and it's new. How do you help them get through the hurdles?
Well, so that statement that the water industry or utilities are slow adopters of technology is pretty common. I think maybe a little bit overstated often, and I don't thoroughly believe the statement because we have utilities that have been adopting technology for decades, and in fact are at the stage right now where they've put so many sensors out that they have all this data and they don't even know what to do with it, right? They recognize that the innovation of collecting data with remote sensors was a great idea. Now what, right? And so I agree with the point that perhaps the water industry doesn't move at the speed of telecoms.
Right.
But make no mistake, water experts have been using modeling, they've been using sensors, they've been using SCADA systems, they've been using databases for decades. So it's really a question almost of owning that and saying, no, we're not slow. We do know how to use technology, but let's use that technology in a way that can benefit the utility as a whole rather than one individual department or one individual engineer, even has been in the past. That's really the trick. So when we go to utilities now, of course, Innovyze has a long history of modeling. And so most utilities we go to, they have a model. They probably have one of our models. Maybe they have one of our competitors' models. But we kind of say, look, you've been creating digital twins for a while now. It's just we want to take it a level up. You've got data sitting over there on a server. You've got a hydraulic model sitting over there. You've got a bunch of new sensors that are out in the field. You've got automated metering. Let's bring it together. Let's create an interface that's usable by a broad range of people, and let's really tap into the power of the technology you've already adopted.
Wow, Colby, that is great, and I'm really glad to hear you say that your view is that water utilities are adopting technology and innovative technology quickly, and it kind of goes to my comment of, yeah, they're a lot faster than they were historically. It also goes to sort of some of the work that AWWA does with our, Innovation Lounge and the work that we do to try and promote innovation. This has been a great talk. I really appreciate your time, Colby. So thank you so much for spending the morning with us and for this chocolate deliciousness.
That's right. I still got my little cup to finish. You've got a lot of work to do on yours.
I'm going to have to work on this hard after we're done here. But I really want to also thank Innovyze for sponsoring Good Day AWWA. You can learn more about them by going to the ACE21 sponsor page and clicking on their logo, or simply go straight to their website at innovyze.com. I hope you'll join me next Monday through Thursday for new episodes of Good Day AWWA. It's going to be a really fun way to kick off each day at ACE21 All Virtual. On Monday, my guest will be the fixer, and on Tuesday, it'll be the closer. On Wednesday, we'll have the New York Times best-selling author, and on Thursday, we're going to have the First Lady of Water join us. I hope you'll join us, and until then, have a good day, AWWA.